Hey guys, 1.4 day 2. You should have out your day 2 notes. Let's go.
All right, today we're going to use deductive reasoning to classify numbers in the real number system as well as use properties of addition and multiplication. So basically when we're talking about deductive reasoning, we are talking about thinking.
We can do it.
I think you've got it in you.
Yeah.
All right, so deductive reasoning, we're going to write out the definition. Your definition should read as follows.
Perfect. Deductive reasoning is process of reasoning logically from given facts to a conclusion.
That is a lot of words. Really what it means is figure it out.
Yep. There you go.
Okay. A counterexample. Counterexample is once you've gone through deductive reasoning and you have proven something to be either true or false. If something is false, you have to prove that it is false by giving a counterexample.
Perfect.
So the definition that we have listed here is an example showing that a statement is false.
There you go.
That's way easier than deductive reasoning.
Yeah.
All right, if you need to pause, go for it. All right, here we're going to use deductive reasoning to decide if each statement is true or false. And if it's false, we're going to use a counterexample. So starting with generic statements.
Yep.
All Pioneer Trail students are 6th graders.
Well, you guys are currently in 8th grade.
So I'm going to go with false.
Perfect.
Okay?
Now, you cannot just write false.
You got to give a counterexample. So what is a statement that we know is true that proves that wrong? Well, there are 8th graders
Yeah.
at Pioneer Trail.
Got it.
Or 7th graders. All right.
Sorry. Hard to read.
Perfect.
Okay. There are 8th graders at PT.
Did you know that she's writing this time?
I am.
I've been writing for the last 2 times. You can't see what we're doing down here.
I know.
All right. So example 2. All PT students eat lunch at school.
Okay. Well, if they're at school,
If you're at school that day,
you have to eat lunch.
You eat lunch at school.
So it would be
True.
true. We did not say bring their lunch to school. We didn't specify any of that. It's just generic, you eat lunch
Yeah.
at school.
Yeah, we have lunch at school. That's
Yep.
what we do. All right. Now don't give me any of that whole, well, my mom took me out to
Well, I
lunch
did.
and I went to the
Orthodontist.
ortho and
Yeah.
we're not, no.
If you're here, you're eating. There you go.
Okay, now we're going to actually apply it to some math. So use deductive reasoning to find out if each statement is true or false. So we're going to say true or false, and then if it's false, we're going to say why, basically, and use a counterexample. So example 3, all integers are rational numbers.
Oh gosh, are you asking me to apply prior knowledge?
Yes.
Oh, Rich.
I know.
Okay.
Gosh, it's so hard.
Let's try this.
All right, if you need to, grab your chart, okay? We've got rocket with numbers, and remember that anything that is I can't point at the screen, but anything that's in the in column is in every subset above it.
Got it.
Okay, so I know that an integer is right underneath the rational.
Uh-huh.
So anytime I have an integer, it is going to be a rational number. So it's going to be true. Right?
Done. Mm-hmm.
All right, now, next one. All decimals are irrational numbers.
Okay.
Well, I know that. Okay,
Well,
so,
decimals stop here, right?
yeah, because an integer can't be a decimal.
Correct.
A whole number is not a decimal, and natural numbers aren't decimals.
Right.
And I know that there are some decimals that are irrational.
Okay, so that's my other category.
So let's think this through. It says that all decimals are irrational numbers. Well, 1.5
It's terminating.
is terminating decimal, or I could write it as a fraction as 1
Correct.
and 5/10,
Correct.
or 1 1/2.
Yep.
Well, that's a rational number.
So it would not be.
That's not irrational. So this is false, and I've already given myself a counterexample. 1.5 is a decimal that is rational.
So I could say a rational decimal.
Yeah. Awesome.
Perfect,
Cool.
guys.
All right. We're almost done.
Yeah, we're rocking.
It's a fast one.
Okay, if a statement is the statement true or false? If it is false, give a counterexample. Okay, don't ignore the counterexample part, guys.
That's
Have to
like
give it
part,
to
you're
us.
only gonna get half the credit.
Yeah, gotta
And
do
it's
it.
like doing it. All right. So for all real numbers a and b, a times b is equal to b plus a.
Well, first off, guys, if you struggle with all these letters right here, then plug in real examples.
Yeah.
So you can say 1 times 2 equals 2 plus 1.
Well, that example is not true.
Okay?
So
So 2 does not equal 3.
Staff, if you have not come down to the library to pick up either textbooks or
No
the
pause.
red organizational binders,
sorry about that interruption. All right, so here we were talking about 2 is not equal to 3. So in this case, this would be a false statement.
And, well, the numbers I chose were false. So does that mean that I should say false for any of the numbers?
Well, this statement's, yeah.
Yeah,
Because
right?
it says for all real numbers. Well, those are real numbers that we picked.
Right,
So, and then they've given another counterexample.
just a different one.
So 5 times 3 is not the same as 3 plus 5.
Right.
Okay, or not equivalent. I should probably use fancy math words.
Eh.
All right, so number B, for all real numbers A, B, and C, the quantity of A plus B plus C
Mm-hmm.
is equal to B plus the quantity of A plus C. Wow, I'm so confused with all the letters.
Okay.
Let's plug and chug.
Let's try it out. So I'm going to go above here. So we'll do 1 plus 2 plus 3 equals, what did I choose for B?
You
So
chose
2.
2.
Plus my A, 1 plus my C, 3.
You chose 3. Okay, so let's figure it out. So on this side, 1 plus 2 is 3.
Okay, so I'm going to go down here.
And then, so 3 plus 3. And then on the other side, it's going to be 2 plus, and then in parentheses would be 1 plus 3 is 4.
Okay.
Okay, so I have 3 plus 3 is 6, and 2 plus 4 is 6. So in that case, it works.
Yeah,
Can I assume that it works for all real numbers?
if it works for the ones you chose.
Then it should work for all real
Should
numbers.
work. True. Use properties of real numbers to show the expressions are equivalent.
Awesome.
Oh, you don't have to write all that, guys. Just
No.
show us the example.
Yeah.
Whoa. Let's calm down.
Doom.
Freak out. Okay.
Okay. Wow, that's gonna, can't wait to hear that 4 more times.
Yeah.
Okay, page
You're
6
welcome.
of 6. We're done, gang. Summary. So tomorrow, we're going to ask you to talk about this. Is it possible to prove that a statement such as A plus B equals B plus A is true by showing there are no counterexamples for the statement? Explain.
Remember, 8th grade level explanation here.
Like, you can't just say, yeah, you can because I just did it.
Just because.
That doesn't work. So really, again, if you struggle with the letters, plug in numbers for the variables.
Okay, bring that back tomorrow.
See ya
Later.
on the flip side.